in addition to atoms and molecules that we had to work with on the particle level, oftentimes substances are present in ionic form. Now, recall that for a neutral atom, such as sodium, sodium would be a neutral because it has 11 protons in the nucleus and 11 electrons around the outside. So you would have an equal number of positive and negative charges. If we take an electron away from sodium, so we remove one electron, we would now have 11 positives in the nucleus and only 10 electrons around the outside. So the way we'd represent this would be Na with a plus, indicating that there's a net positive charge for one more proton than there are electrons. Now, what oftentimes gets confusing for students is they see the plus and they think that you've added electrons, and that's not the case. Also, it's important to remember that you can only add or remove electrons. You can't change the number of protons because that would change the element itself. If we take a look at a similar case with a non-metal that would tend to gain electrons, for instance, chlorine. Chlorine has 17 protons in the nucleus and 17 electrons around the outside. For this element, it wants to add one electron. And so you would then have, again, our 17 protons in the nucleus, but you would now have 18 electrons outside of the nucleus. So the chlorine would have a net negative charge. So we would write down Cl minus as the charge there. If we were going to do a reaction between a chlorine atom and a sodium atom, so we take a sodium atom and a chlorine atom, and we thought about that sodium losing an electron and the chlorine actually taking that electron, we would then form an Na plus and a Cl minus. Those two ions would be attracted to each other because one is positive, one is negative, and so you would have what's called an ionic bond. What we want to be able to do with these then is to predict the formulas for these ionic type of compounds based on the number of electrons that were gained or lost. So in this case, it was rather simple because sodium lost one, chlorine gained one, so we would write down the formula simply as NaCl, sodium chloride, which we're somewhat used to with table salt. But let's take something that's a little bit more complicated. Let's take a look at, say, a magnesium and fluorine. Or actually, let's just use magnesium and chlorine. So magnesium is going to tend to form a 2+ ion. So if you look at your ion sheet, magnesium will form a 2+ ion, which means it wants to give up 2 electrons. So I can kind of visualize what's happening here, draw what I'm thinking in my mind is that magnesium is going to give up 2 electrons. My chlorine, as we just discovered in the last one, only wants to gain 1. So in order to make magnesium happy, I'm going to need to find another chlorine to take that second electron. So now if I'm going to write the equation for this, I used up 1 magnesium and 2 chlorines. So the combination of 1 magnesium and 2 chlorines ended up so that the number of electrons that were lost is equal to the number that are gained. You can also look at it from a balancing of charges standpoint. Magnesium losing 2 will become a 2+ charge. Chlorine gaining 1 will become a 1-. In order to balance out the charges, which is really just accounting for the electrons that were transferred, you would need 2 chlorines to balance out with the 1 magnesium. And so we'll do a bunch of practice with these. The other one that you'll see is with perhaps an ion, a polyatomic ion. So if I take sodium and sulfate, SO4. Now, this sulfate ion is going to tend to have a 2- charge. It wants 2 electrons. Well, again, if we kind of go through the mental work here, sodium will give up 1 electron. That sulfate wants 2. So that 1 electron for the sodium is not going to quite, won't quite be enough. So I'm going to need another sodium atom to give up another electron to satisfy that sulfate. So here we would have 2 sodiums that would be needed to balance out with the sulfate. Notice though that I deal with the sulfate all together. I don't split up the sulfurs and the oxygens. I deal with that all as just one ion. So we had our Na plus was the positive ion and the SO4 2 minus is the negative ion. One more example. If I were to take, say, an iron that wants to lose 2 electrons, so we'll draw iron losing 2 electrons, combining with a nitrate, which wants to gain just 1. You see it's just a -1 charge there. So if I put the NO3 here, and 1 electron goes to that nitrate, and the other electron goes to a different nitrate, so you can see that our balancing of the charges is going to be Fe, but now I want 2 of the nitrates. So the way that the system we use to deal with multiple atoms here, we can't just put a 2 underneath each nitrogen and oxygen. So what we're going to do is we're going to take that ion, write it down as it is, and then we're going to put brackets around it and put a 2 outside, indicating that we need 2 of that entire ion. And so you'll have some examples of these that we'll work with in class. And again, it's just a matter of, as always, practicing and getting comfortable with writing these types of formulas.